All right, here we go. The last video. We're going to finish up C and D. We are not going to get to example 4, but you're more than willing to try example 4, and we'll talk about it the next time we see each other. But we're going to do C and D. C is asking for the open intervals between 0 and 2 when the particle is moving to the right. So what does that mean if the particle is moving to the right? That means the velocity is positive. Positive. Or you can say the velocity is greater than 0. Well, the velocity is positive here. So it's in between these 2 points. The velocity is negative down here. The velocity is negative down here. But in between those blue points, the velocity is above the x-axis, therefore it's positive. Oh, but we just found where those 2 points are. We said those 2 points are at 1.225 and at 1.801. So therefore, we can say the particle moves to the right on the interval of time between 1.225 and 1.801 because the velocity is greater than 0. Maybe I'll call this velocity v of t because that's what v of t stands for, the velocity at time t. So the velocity at time t is greater than 0, the velocity is positive, and that's how I know, that's my justification that this is the window of time where it's moving to the right. That's it. And then finally, part D, find the acceleration of the bug when the velocity is equal to negative 1. Well, wait a minute. In order to find the acceleration, I need to take the derivative of the velocity, but I also need a time, and I don't have a time. So I need to figure out a time first and then plug that into the derivative of the velocity. So how do I figure out the time at which the velocity is equal to negative 1? So I can look at the picture, and I can look at the picture and say, oh, look, at time here, whatever this time value is, I don't think it's not that blue point, but at somewhere between 1.5 and 2, at that time, it does cross the negative 1, and therefore that's when the velocity is negative 1. This is where a calculator can help us solve. So I know the velocity is equal to negative 1 if I take my graph and I go to my window, I go to my equation editor, and in Y2, I'm going to type in negative 1 so that I can see where exactly is it. Oh, it's right here. Well, let's find the intersection of the blue curve with the red line. So I go to second trace. We're going to find option number 5, the intersection. And it's going to ask me 2 questions. The first question down here is this curve, is this equation in blue, one of the 2 curves you want to find the intersection for? Press enter, it is. Next question, is this curve, the red line, the second function you want to find the intersection for? Press enter, yes. Do you want to take it again? I don't, so press enter, and it's going to give you the intersection. So at time 1.837, the velocity is equal to negative 1, 1.837. 1.837. And so some students write it down and then they walk away, forgetting that, oh, we were supposed to find the acceleration. And the acceleration is the derivative of velocity. So now I can find the derivative of velocity at 1.837 seconds, or whatever that is. So I use the fact that the velocity is equal to negative 1 at this time, and now I'm using that time to find the acceleration, which is just the derivative of velocity evaluated at 1.837. So I go back to my calculator and I say, okay, hey calculator, go to the home screen. We're going to run a derivative because we want the acceleration. We already have the variable. We already have the formula. Alpha trace can allow us to put y1 in there. And now we have the actual time where that's going to happen. 1. Now I forgot what it was. 837. 837. Press enter, and you get negative 28.877. Negative 28.877 equals negative 28.877, I think it was. I do want to point something out, and this might be helpful. Actually, it will be helpful. If I press X and press enter, notice how the calculator remembered the X value of the intersection point. So the calculator has like short-term memory. Whatever the last X value you found, it still remembers it. So if you press X and press enter, it's still there. I say that because we could have done math 8 with derivative with respect to X of the equation in y1, but instead of typing 1.837, since the calculator remembers the full value, I can just put X, press enter, and here is a more accurate answer. Notice that it's off from the one I wrote down. Why? Why is the one I wrote down on the paper not the same as this one? And it's off in the third decimal place, which is bad because I need it to be correct and accurate to 3 decimal places. Well, I cut off the answer. Not only did I cut off the answer, I rounded the answer. So when I rounded the answer and then I used that answer to plug into the derivative, well, then that threw it off, right? I had propagated error. So here, this is the actual retail price. Negative 28.874, I think, might be the better answer for this. 874. So either use another decimal place, so use 4 decimal places to do the calculation and then round the answer to the decimal places, or you can use the full decimal using the calculator's short-term memory and get the answer that way. The moral of the story is your calculator can help accelerate some things. And so our goal is to practice using the calculator, especially for problems like this. And we'll look at some free response problems about motion next time.